Hello, my name is Dan Weiner. I am a PhD student at the CUNY Graduate Center. I am currently working in the Tier Lab under Dr. Raj Korpan at CUNY Hunter, where my research is primarily focused on multi-agent robotic systems. I'm in Group 5, which involves 3D input, and my demo scene will be about the MetaQuest controller. So 3D input in AR, VR, and MR means reading everything that the controllers report. Not just buttons, but where they actually are in space. So Unity exposes this through the XR input system. This means you get a handle to a device by its role. So then that's the left hand, the right hand, and the headset for my setup, which is just the basic MetaQuest 3 setup. And then you could read named features off of it. Those feature names, which are like trigger, grip, primary button, device position, actually come from a standard vocabulary called common usages, and OpenXR maps whatever physical controller you have onto that vocabulary. That's why I can use my meta controllers and somebody else can use like Vive controllers or index controllers. And that abstraction is why the same code will run on all of those controllers. So during my demo, I have a couple things to show you, but I wrote 2 scripts for it. And this is just the basic VR scene that you get with the VR build from the Unity Hub. So first is haptic feedback on press, which just basically gives you haptic feedback when you press the trigger hard enough. This is only on the right controller right now. And then this is a readout, a debug readout, which I put on a UI canvas, and I put a text mesh Pro display inside of that, and it basically gets these values from the common usages library and outputs like the primary button, the secondary button, the trigger button, and it outputs their values. So it tells us what is actually happening with both hand controllers. So for the next part of the video, I'm actually going to go inside the scene and record and stitch them together. So hopefully that works. And I'll see you in a bit. So here is the VR scene that is basically the default VR scene that Unity has set up for you. I deleted some UI elements. I left these interactable elements, and I added these guys right here, which are debug elements. They basically tell us what's going on inside the system with our controllers dealing with 3D input. So the first part of the demo has to do with buttons and analog. So the panel is every frame, the panel grabs both controllers' information and reads their features. So if I press the buttons, you'll see that these are Booleans. BXY button, press true. That's a jump button, so we're not going to be able to see that. This one, true. This one, true. So this one does turn true. You can see it there. Very hard to tell because we're jumping during that. But you can see we could turn all of those true. They're just simple binaries. And then we also have the thumbsticks, which are like 2D motion, meaning it's on an XY plane. So you can see the stick for the left hand here and the stick for the right hand here. So if I were to press forward, I forgot that it's smooth motion. Okay, so if I press forward for the right stick, you can see that it goes 1 and basically 0, because it goes between 1 and -1 on both axes. So like full forward is y1 x0, full right is x1 y0, full back, and you could actually see the thumb stick doing this. Full back is supposed to be x0 y -1, full left is x -1 y0. This also does this. Unfortunately, I can do it slowly so that you can see, but if I press it, the smooth motion kicks in, so it's kind of hard to see. And then there's also the triggers, which both have continuous values between 0 and 1, and binary booleans. So there's 2 triggers on both controllers. So if I press this in, you can see it actually being pressed. If I press it slowly, you could see it slowly goes towards 1 from 0, this one as well. I don't know if you can, yep, that one goes in as well. And the threshold right now is actually 0.5, which I believe you can change, but that's when it actually changes from false to true. The same thing over here. It will change from false to true. Now, the next part is actually the 6 degrees of freedom, which is genuinely the 3D part of the input. So let's take the right controller, for example. We have position and rotation. So we can try and, it's very hard to actually get I've tried this before, it's very hard to find the actual axes, but if you go up and down, you can see that the y-axis is changing the most right now. And let's try and go away from the player, back towards the player. It looks like the X and the Z axis are changing very fast. And if we go this way, okay, so I think that's the X axis, which would make something like that the Z axis. But you can see that we can actually get these positions in real space. And of course, the same goes for this controller. If we put them very close to each other, they'll be essentially at the same spot. Now, there's also rotation. So this one's a little bit harder to show, but I have a desk in front of me. So if I put it down on the desk and I turn it just by itself, you can see that just the x-axis is turning right now. So that's, I believe, the x-axis for the right. Now if we try and turn it this way, we get a much stronger y-axis input. And then the z-axis, I'm not 100% sure, maybe like this, the roll. But yeah, we get its full position in 3D space with 6 degrees of freedom, which is what separates VR from a fully flat gamepad. We also have velocity, which is represented as speed in meters per second. So this is how fast the controller is literally moving. And this is also the foundation of my course project. So my gesture recognizer system, when it's working on heuristics, it's going to basically be looking at hand position and speed. So a hand that's held out roughly vertically and is slowly extended towards the player would, towards the avatar, would most likely be a handshake. A hand that's held up vertically and has an oscillating velocity from, back and forth, is most likely a wave. So this is also a very, very important indicator of what's going on. And we could actually use the speed to see one of the more interesting aspects of this. So if we grab something and we go here. So if we just throw gently underhand, we'll see that the throw will actually be corresponding to the speed. So this is just like a gentle underhand throw. You could see it goes not very far, but if you do a real overhand harder throw, because of the speed, you get a much further throw. And this goes towards immersion. If this type of thing didn't happen for the player, it would break immersion almost immediately. This also goes towards this also points towards interaction with all of the things around me. So like this was just built-in part of the Unity scene when I got here, but you can basically pick things up and manipulate them in the scene, passing them from hand to hand, making them bigger, making them smaller. So, it's actually quite fun to play with, rotating them and stuff like that. So it's very interesting. But yeah, so it actually feels like you're picking things up and holding them. And then there's also haptics, which I put into with one of the scripts. So if you see, I'm holding a confetti gun right now. So I know you can't feel this watching the video, but when I press the trigger, it shoots confetti, and the right trigger specifically, the right controller, has haptic feedback when you pull the trigger and it passes the 0.5 threshold. You can see if we go slowly, once we hit 0.5, it shoots, and it has a small vibration, nothing too significant, but it adds to the immersion, just having that little bit of haptic feedback. And it also closes the loop such that, the user acts and the device responds physically and accordingly to the action. I don't have it scripted on the left hand to have the haptic feedback. So when I pull this, it feels completely different to have it shoot, because there's no physical feedback in this hand, as opposed to this, where I actually feel something happening. It's a much different experience. Yeah, so that is basically the full rundown. And yeah, the buttons in analog are discrete. The 6 degrees of freedom, as we can see, are continuous. And we can use tracking, velocity for spatial input, haptics for feedback to increase immersion, and that spatial data is exactly what my gesture system will be eventually built on. Thank you so much.